All right. We did it. We made it.
Yeah,
How are you doing today?
I'm amazing. I'm amazing. It's almost a sunny day in Germany, which is not that bad. It's plus 10 degrees Celsius here. There is no snow, so we're alive. It's a smell of spring, I think. It's
Fan.
coming. Spring is coming.
I mean, spring is nice. Spring
Yeah,
is
spring
nice.
is.
You have that right. My screen, I need to fine tune it because one of my screens isn't working. So I'm going to hit a button and I'm going to
Yeah,
try
I
to
mean,
fix the
who needs
screen.
two screens
Yeah. Or four.
for
Right.
seven screens? Like in this nuclear power plants, they have like nine screens or 16 screens in a huge, I don't know, what is it, rectangle?
Yeah. And
Probably.
the array.
They somehow can read all of them at the same time. If something goes wrong, yeah. So, do you feel like this power plant operator?
Yeah, I do. I had a data center in my basement for a while, for quite a long while, for like 7 years.
Oh wow!
And yeah, I hosted 20,000 domains or 19,000 something, like approaching 20,000 domains in my house. And I did all the management, all the stuff for all that. And then 2008 happened.
Yeah. How
So then
many
that.
screens did you have back then?
So I had a VGA screen on top of each rack.
Oh wow!
And what I was able to do, I used I can't think of the name. The thing where I had one keyboard and mouse, and I
Yeah.
could scroll my mouse across all the different screens around
Oh
me.
nice.
So 7, 8. I think there's 8 monitors total. But I could control them all with the one keyboard and
Do you know
mouse.
what kids do these days?
What do they
They have
do?
this portable HDMI screens, like 15-inch screen, and they just detach it from one, attach it to another. You can attach it to USB or HDMI or whatever,
I think I
and
have
do
one of
work.
those right over. Is that a reach? One of these bad boys?
Yeah, one of these boys.
Yes.
Right. I mean, this is probably what you need to run 100 tracks these days.
Yep. Yep.
Because you definitely do not want to have VGA monitor on top of any of them. Can you still buy anything with VGA output?
I don't know. I haven't tried. But I do have a computer here still that has a VGA connection on it.
Nice.
My wife's grandmother was complaining that her computer was slow. So I traded her one of my fancy Nooks that had 64 gigs of RAM, and it was the Intel i7 or something like that. And she only uses it for her web browser.
Well, I mean that's what people do, right? So usually I hear people complaining that Linux is not built for home usage. My wife sits on Linux for like last 8 years. She doesn't even know that it's Linux because what she does, she uses
Yep.
Chrome or whatever
Yeah.
and some text editor. It's LibreOffice or something like that. It
Yep.
works. It's enough. Yeah, it's just a tool. You don't need anything else.
You're right. You are right.
Well,
Pasha,
I mean, when you are not a tech-savvy person like I am.
we have a few folks showing up. Good morning. Karen
Good
Beer,
morning.
very nice to see you. It's evening to the Indian friends and Asian friends. Absolutely. Cats in the house. Hello,
Yeah, yeah.
hello.
How's it going?
And things are good. And Ian's here. Ian's here.
Oh,
Things are
nice.
good.
Hi, Ian.
And yeah, if you're joining us live, my mom and dad are always watching, and they always like to see where everybody's joining from. So let us know in the chat where you're joining from, because mom and dad are always watching. Hi, mom. Hi, dad.
Yeah. My
And
my parents are probably at work right now. I do not believe they watch us. It would be nice though. Well,
last time we chatted,
they always complain that I talk on too deep, too technical things.
yeah, my family, they like to watch. They'll see, and they'll see where people are coming from. But I also have a few relatives that'll watch for a little bit, and then it gets a little deep.
Yeah.
But I'm glad that they're watching. It's always fun.
Why did you stop hosting those domains?
2008, when
Oh,
the
okay, well, I mean,
global
oh,
market collapse.
oh yeah. So Did you think these days about hosting again?
Yes, I do actually. Great question. So these days I have about 100, somewhere around there, I lose count, about 100 Raspberry Pis. And these Raspberry Pis, some of them with 16 gigs of RAM, are way more powerful than
That
the
anything.
servers that I used to host back in 2008.
Yeah, absolutely.
So in my head, if I was hosting, 20,000 domains, and most of those were WordPress. So there was the website, plus the database that was going along with a lot of those, and I was also doing email and FTP and all those good things. And I figure if I was doing that many, I could probably do a few thousand websites on a handful of Raspberry Pis,
Yeah,
especially
absolutely.
now that I know so much more, right? Now that I've
Yeah.
got like, yeah, yeah, better
Would you host
processors.
them? Would you host them on Kubernetes cluster or just, I don't know, randomly?
I would host them on Karifi. So
Griffin.
Ian, who's in the chat, I walked him through how easy it is to deploy images to Karifi. I did a CF push, and Karifi, for those that don't know, is it's part of the Cloud Foundry API implemented on top of Kubernetes. And that's what I've been playing with for a while, and that's what I'm going to do. And what I'm actually going to do is I'm not going to charge people for hosting, but junior developers that are looking for a place to host their projects, I'm going to give it away. And I don't deploy active passive in my house. My children will never deploy active passive. So
Yeah.
I've got two different internet connections coming in, and I will deploy to two different clusters of Karifi. And that kind of brings us to today. Because we don't deploy active passive in this household, we like to we like to have solutions that work in an active fashion.
Yeah.
And we were talking about this a little bit last time.
Yeah.
One of the things that's kind of crazy these days is search, right? When I was
Yeah.
doing search for the longest time, it was all the different ways we could index our database columns. And yeah, and every database had some sort of full index search. And
We
then,
probably shall do a small overview how you would implement a full text search on Postgres, right? You would
yeah,
probably have a text column containing an arbitrary data. I think if it's books, it's descriptions of books, names of books, years of their book publishing, and so on. Then you will somehow, if you're bad, if you're really bad, you will just search by like percent, something percent. It will be crazy slow and impossible to improve on. Then if you're slightly better, you would probably use trigram indices or gene indices in your Postgres, and you would try to implement full text search, and it would be really slow, and
yep.
syntax is very, very painful. So what did you do like 10 years ago, 7 years ago? You would install Elasticsearch.
Before Elasticsearch, I would use Lucene.
Yeah, but Elasticsearch is essentially built on top of Lucene, right?
Yep. So
So
we kind of had this progression. Again, every app that we ever took to production wanted some type of search, and unfortunately, the first generations did require you to know some weird syntax that you would allow, the like percent or whatever, which was okay, but dangerous and not real friendly. And people were comfortable with it for a long time, and then they weren't. Right once the first competitor started using regular search, like a Lucene or an Elasticsearch, then everybody kind of had
Solar,
to.
do you remember Solar?
Solar, yeah,
It's another. It's still alive.
right.
Still not a
Solar is
big
built
player
on
on the
top of
market.
Lucene as well, right?
I'm not sure. I think
I think. But yeah,
maybe you're actually right. Maybe you're right. So in Java world, it seems we have only one full text search engine, and it's called Lucene, and everything else is built on top of it. Solar and everything else is just two products, Solar and Elasticsearch.
those are the ones that are in my bag. Those are the ones I've taken to production.
Yeah,
Solar, Lucene, Elasticsearch, full text search. That's what
yeah,
I've taken to production
yeah. But
until
they are very hard to maintain, and one could argue they work slow, right?
Yep.
I mean, it's not like it's not their fault. The Elasticsearch consultants will always say you there is a way to speed up things. It's just you should be really good to speed up it, and then your next solution comes in, right?
Yeah.
Because you have a kind of cheap solution.
Well, what I've been saying for a while is that the simplest vector similarity search with any of the vector databases, the simplest vector similarity search is way better than every solution that I ever took to production before that. Just by throwing everything into a vector similarity search, I'm getting better results. I have a better interface. It's better out of the gate.
But you have issues with it. Like you have to build vectors for everything.
Yes.
And it's not an exactly precise science, isn't it?
It is not.
If you have two similar names of a book or for a movie, then how would you distinguish them? They will be almost the same.
Yep.
You have to train your model very specific. Should we clarify about vectors? What are they? How do they work?
Yeah. Feel free.
I mean, if you don't know what vectors are, we actually have a blog post in Belsoft's blog about it. But the basic idea is there is a multi-dimensional space of 1,871 dimensions, more or less, in which you can describe any text as just a point. And the point is essentially a vector. And when Deshawn says that we can perform a similarity search, he means that two vectors from one term or from one text, and cosine distance between them is very, very small. It's like they're really tight, they're really close to each other. And if they're like this, it means they're less similar than if they're like this. And this is what is called similarity search in a vector database. Did I grip it correctly?
Yes, I agree. Three-dimensional space, think of a bunch of lines pointing in different directions. If those lines are close and pointing in the same direction, they're similar. The example that made vector similarity search really hit for me, I got from Brian Samboden in one of his talks. And he talked about like king being a vector pointing one direction in a different place, and a fish. It's an animal, so maybe the ends are near each other, but it's pointing in a completely different direction. And then he did this king minus man to give me a different vector, plus woman equals queen. And you'd get this kind of like, oh, I understand, thinking of these vectors as floating point generated vectors, and you could do this type of math to find out how things are related inside of this three-dimensional space of vectors. And that was the thing that hit for me. Once I heard that.
I actually have a video showing this idea. I posted it in a private chat. It's like 30 seconds video. I'm not sure if you can share it, but if you can, probably. It might make a little bit of sense.
Oh, is it one that I need to download?
You can download it.
Oh, hold on one sec. Let's see.
It should be relatively small, like several megabytes.
Yeah, let's take a look. Let's see if I can pull that up.
I'm not sure what's better. Is it WebM or MP4? I have both of them.
Oh, here, hold on. I got to pull it to another screen, but it looks like it's working. And I will share that screen.
You can present video file in StreamYard, you know?
Yeah, I'm gonna do it
straight up
this way.
present video file.
Ooh. Hit that button, and let's see if I can watch this. Is there audio?
No, there is no audio.
Okay.
Oh, it's a different one. It's actually, this one is also interesting. It's about cosine distance with yeah, we'll see. There is a small bunch of maths, but we'll not. But imagine there is a rose, sun, and sunflower. And
Yep.
Sunflower is obviously somewhere between rose and sun because it's flower, but it's somehow connected to sun. and smaller cosine distance. And cosine distance is just the small angle between vectors. It means more similar meaning. And now I see that the video is too fast. Do you wanna watch another one?
Yeah, send it.
Yeah, give me a sec.
This is all, like I said, these types of search are so much better than most of the things that I was taking to production.
While you're downloading it, if I remember correctly, some time ago you told people to use Redis for full text search.
That's my default.
Wait, what's your default? Is your default vector database with embeddings?
It's both. It's both. So my implementation that I'm working on right now, because of our last conversation, is I'm using Redis search. But I was thinking about going and implementing both. That's one of the nice things that I can do with Redis is I can have my vector data stored in the same instance as my search data. So because the data that I'm indexing is Markdown for my static websites made with GoHugo. So I've got some of that front matter data, when it was written, the tags, the content, if it's a part of a series. I have that I can index, and I can put that into my my Redis search, and I can have those index columns. So, hey, find articles written by this date or whatever. But I can index using vector similarity search summaries of the content. So I'm not there yet, but this is an approach that I can do in the same tiny Redis instance. Here's our.
Let's watch video and then switch to.
Yeah.
So this is this king and queen analysis.
Yes.
Imagine we have king and man, and king plus man will be this long vector, but we actually have to deduce man from king, and it will be like some synthetic vector. And we also have some vector for woman.
Yep.
And when we do king minus man plus woman, we actually get queen. And this is exactly how it works.
That's the one.
In vector databases, they just do deductions and additions, and you have all this magic.
Yep. That's the example. I don't know who came up with that one, but that's the example that really made it stick for me. That's the one that glued it into my head. Okay, now I know I have my head wrapped around this vector concept.
By the way, folks, if you have any ideas of the same example without, I don't know, gender affinity, I would be grateful. It's this one is so obvious, but I just couldn't come up with anything better. I am not a huge fan of man, woman, they're very relative. It's a huge spectrum and so on. So we probably should change it. I just don't have any ideas. If you have them, come to me, talk to me. Let's improve it.
Good idea.
Yeah, by the way, the library I used to create these visualizations is called Manim. It's written in Python. I'm a Java developer mostly, but it's written in Python. And the whole channel called 3 Blue 1 Brown, all animations on this YouTube channel are created with this library.
Okay.
It's just amazing. It's like, I don't know, 30 lines of code, and you have these nice visualizations. They cost almost nothing. They're very, very, very fast to create. And they, in my opinion, are kind of visual. They're really helping me to visualize things and understand something. And then I can try to explain it to someone else. So, should we jump back to our Redis search? So, how do you compare Redis search and, I don't know, vector databases? Which vector database do you recommend, by the way?
So you might guess that I start with Redis. And I'll be honest, my exploration, a lot of folks are using PG Vector, but sometimes the vector database, depending on what you're using it for, sometimes these different vector databases have different strengths and weaknesses. And this is the thing that I say about databases in general. I've done a lot of really awful things that in a relational database like Postgres. I've done awful, horrendous things that should never be done with Postgres, but that's what I had available. And the way that I look at things, right? If Postgres is what I have available, then that's kind of what I'll default to. But because of my fondness for Redis and because of all the different ways that I can use Redis that are kind of built in, right? It's got the multiple data types that I can use. And I got a lot of experience with it. So that's just the one that I pull off the shelf first. And it does
Yeah.
have vector capabilities. So that's the one I
It
pull
means
first.
it makes a lot of sense. My question is, Postgres has like a handful of on finding of a handful of ways to find similarity between vectors, cosine distance, whatever else. It has many. Is Redis as powerful as Postgres in this regard?
I'll be honest, I don't know the answer to that.
Okay, but you're saying that Redis is fast.
Redis is fast.
How do you create vectors for Redis? Do you create them with OpenAI or with Llama or with something like that?
Yeah, I have the different types. I have options, and I don't know which one I default to. It's probably the OpenAI embeddings. But let me take a look. Let me see.
I mean, OpenAI
Yeah.
sounds reasonable. Why not?
Yeah.
I mean, these days, ChatGPT is essentially the default AI, I think, and it makes the OpenAI default models for everything until you have very specific demands.
Yep.
For example, if you prefer to write backend code, then they say that Cloud, is it Cloud or is it Claude or what's the correct pronunciation?
I say Claude.
Okay, Claude. Okay,
Yeah.
Claude. They say that Claude is better for writing backend code for you. This is my default in AI assistant in IntelliJ IDEA, by the way.
Uh-huh.
But, well, I mean, the difference is not that big at all. Also, DeepSeek is also very interesting. They
Yes.
say that DeepSeek understands Kotlin the best of them all.
That's very interesting. That is very interesting.
I didn't.
Here's what I do know. I realized last night that I stopped paying for ChatGPT. I like to run my models locally
On Raspberry Pis?
on Raspberry Pis. I also have some bigger machines. I've got a few NVIDIA GPUs. I got two 4090s. I also have the NVIDIA Jetson
Man, this
Orin
is nice.
Nano. So I have different models running everywhere. And there's a project that I haven't gotten running yet that's called EXO. And that is something that I would have liked to get done before I start traveling. It's EXO. And it provides the OpenAI API. So you can run it. But what its claim is that I can have a bunch of machines and I can deploy DeepSeek, and it'll put different layers of that model on different machines. So I can use the combined power of the machines that I've got it deployed to, and it will, give me better performance. So an experiment that's coming soon will be to run that EXO across Raspberry Pis and see how it compares to just running on a single Raspberry Pi to running on an NVIDIA GPU. But I lean into Ollama heavily. That is my default way of delivering LLMs in my lab.
You do not have an awful lot of time because your first travel is like in a week. The
Yes,
next
my first
starts
travel is
in a week,
Monday.
right?
Yep. Are you going to be at DevNexus?
Yeah, I'm
Oh, yes. Okay, fantastic. That's good. That is good to know because I was debating on.
we need to record some shorts, whatever's.
Yeah, we will
Well,
absolutely be coming. Dan and I are going to be recording a Spring Office Hours episode, so we'll definitely do that. And I'm bringing Dan's bringing his cameras. I bring my audio equipment, and we will definitely do some recording.
Yeah, I'm bringing my gimbal. I'm bringing my microphones. I mean Bluetooth ones.
Yep.
It's a nice setup for in the field recording at least.
Yep. Let me just say this, Pasha, like we don't have to do anything. I just like hanging out and talking with you, and I'm glad that we get to do it here live. This is fun. So
But
the first
I
time we
caught your
met.
drift. You're saying me that Pasha, show us the code, right?
No. I'm saying I enjoy hanging out. If we get to the code, that's fantastic.
Yeah,
But
because I have a code to show, but yet we were talking about
Raspberry Pis and AIs and vector DBs and Yeah, how we're going to do it.
And
There's tons of
last
options.
time I mentioned mail search, didn't I?
Yes.
And at that time, I just knew that the thing exists. Hi, Manos. But since then, I have published to Maven Central a library which allows you to connect mail search to Spring in like this.
Let's take a
You
look.
just, I don't know what should I show you the, let's jump to the code.
Let's just jump in. Let's see. Show me. Oh, I lost you. That's okay. We'll keep going. You'll find the button and you'll come back. Hey everybody. This is kind of like how things work. We hang out with friends.
You just saw the first episode of Pasha Jumps. Out of the hole.
This is
so
what we do.
Let me try again. Let me try it again. I will share the whole screen probably. I have nothing to hide from you.
Okay.
I have my idea here.
All right.
Yeah, so
I'm going to bring that
idea
up.
is the following. Folks, do you know, please type yes in the chat if you know what is Spring Development Time Services are.
Spring Development Time Services.
Dashon, you definitely know what it is, right?
I think that I know what it is.
Yeah, so idea is the following. You have compose file in your project, and this compose file starts, I don't know, Postgres for you, or Redis for you, or whatever database of your choice for you. And in runtime, you do not need to have any application properties or application YAML, which allows you to connect to this Postgres or whatever. It allows you just have data source automatically. I actually have something. Let me show it. Yeah, here it is. Is it readable? Now
Yep,
it's readable.
there you go.
Yeah, so you add one dependency, Spring Boot Docker Compose. It should be marked as optional in Maven. In Gradle, it's just development only, because you do not need it in runtime in your production. It is only to work with your actual compose file, only for your development purposes. What it does, it's very simple. It looks for compose YAML in your project. When it sees compose YAML, it calls Docker Compose up. And when you start the project from your IDE, or I don't know, from your command line, if it's your way, and then when you stop your project, it calls Docker Compose stop. Not Docker Compose down, it's important. Docker Compose stop. So all your data, even temporary data, is preserved. If you want to delete it, you will have to call Docker Compose down manually. And it already supports a lot of different services. ActiveMQ, Artemis, Cassandra, Elasticsearch, we were talking about it, JDBC, MongoDB, Neo4j. Will I find Redis? Yes, Redis connection details. So if there is an image in your compose file called Redis or Bitnami Redis or Redis stack or Redis stack server like this,
Yep.
it will know, your application will know, even without properties defined in your application properties, how to connect and work with your Redis, which is, in my opinion, amazing. It just makes everything so much easier. You do not have to install Postgres on your machine if you want to develop locally. You don't need, I don't know, to call Docker Compose up manually and then somehow connect properties to this Docker Compose. You don't have to do anything. Spring will do its magic.
Yep. This is
by its own.
This is a feature. I believe it came out with Spring Boot 3.1.
Let's see.
And it came
I think it should be something
shortly after.
Sounds about right. Maybe 3.2.
Yeah. Test container support came right around that same time, and I struggled.
Yes, me too.
The test. We had a test application context that would just kind of load the application context, but then also provide test containers in that same way. So you could use test containers to have your databases to do your things, but you could run it. You could run that test main.
By the way, test containers could be an amazing solution. The only issue is you usually do not want to have test containers in your development setup because this code will go to production, and it means that your production will try to start up test containers, and it's definitely not something you want to do, right?
Yeah, I get it. Test containers
there
is
is
nice.
There is a way to create your own development time services. And it's actually relatively simple. Let me show you. Here is my project. I should probably go to presentation mode. give me a second. Present.
See, you're such a pro.
Something like this. Come on. View. Appearance. Presentation. I see. Enter presentation. Wow, there is no hotkey for it on Mac. So I have this README here. This is how you connect the thing. You just add this dependency, com GitHub Asmodee Spring Mail Research, and then you put version there. I forgot to tell what Mail Research is. Sorry for jumping between windows.
No, it's okay.
Let me look into it for you. Mail Research is actually a full text search engine. It's very, very simple. I mean, it's very fast and very simple. It's written in Rust, if I remember correctly. They say that it's lightning fast, plug and play, and ultra relevant. It also has all kinds of connections to AI stuff. So if you want to have intelligent search, you can do it both on premises and in cloud. But even if you don't want, having just a good, nice working full text search engine is amazing thing. So this was like 2-minute presentation of 1-minute presentation of Mail Research. Here is how you write your, come on. Now I can switch between projects. What is going on? Spring Mail Research. Yeah, here we go. This is a very small project. It has what? 5 classes. Mail Research auto configuration, which says that if we have client class on the class path, and client class is just a part of Mail Research SDK, then we enable configuration properties called Mail Research configuration. If we have these properties, we create new properties from the connection. Otherwise, we can read data from connection details provided. Okay. There is this complex class called Mail Research Docker Compose Connection Details Factory.
So because you made a starter and you're supporting the Docker Compose support.
Yes.
Okay.
Because this is how you name things in Spring and in Java. It should tell everything about it. It should have no secrets at all.
The nice thing, right? Here's a fun fact.
We create multi-search, Mail Research configuration from Docker Compose connection, and we create Docker Compose connection multi-search connection details. Mail Research connection details is just a very simple interface. It implements connection details, which is nothing. It's just an empty interface with 2 functions: address, which returns a NetSocket address, and string key, which is just a master key to our Mail Research.
Okay.
It's all documented here. Mail Research Docker Compose Connection Details Factory. One day I will be able to pronounce it without stopping. Knows that we are looking for an image called getMaily/Mail Research because it's an official image of Mail Research. And yes, it passes the class of client. Then it creates Mail Research Docker Compose Connection Details. It's not factory already. And they're very simple. They say that first we are looking for a port 7700 to which port it's mapped to create an in-net socket address. And also we are looking for environment variable called Mail master key. This is how it's defined in official image. If you have your own image with Mail Research, you will probably have to somehow redefine this environment variable. It's not that hard, and the Spring part is very, very good documented. You actually can build your own image if it's compatible with my image, with official image, and it will work flawlessly with one additional line in your Docker Compose. Nice. This is essentially all the magic. Yeah, we also have this Mail Research properties, which just a record with 2 fields, API 3 fields, sorry, API key, host, and port. What else do I have? I don't even... Yeah, and we have an implementation of Mail Research connection details on top of our properties files. So if you have properties defined and you do not have a Docker Compose file with Mail Research, then Spring will read all the data, all the needed data from the application.properties or application.yaml or whatever from I do not remember, mailysearch dot something.
Yep.
If you do not have it and you have Docker Compose file, then it will read all the data from Docker Compose file. And if you have both, then it will try to read from Docker Compose. And if Docker Compose is, I don't know, it doesn't start, it doesn't match our image or whatever, it will fall back to the properties.
Okay.
It will also work if you have test containers, which is also amazing. But test containers in test, you need to put one additional property that you do not want to run your Docker Compose in tests. It's literally one property in the properties file, and it will work with test containers with mailysearch too.
Fantastic.
Now, give me a sec. I have a small demo here.
Let's see it.
First, it's written in Kotlin because, again, Kotlin is just a language of my choice. So this is the main class, which is just Spring Boot application. No magic involved whatsoever. Let's look at my dependencies. I have mailysearch Java client, and I have my own library, Spring mailysearch. Other than that, I have what? Spring Boot starts a test, Spring Boot Docker Compose in development only, as recommended. I have Spring Boot start a web, so very, very simple.
Okay.
And I have a very simple controller, which can load CSV data into our mailysearch. It's just, I have a huge CSV actually.
Do you have this repository? Is this repository public?
Yes, I have them both.
With your demo?
Of course.
I'd love to throw that link into the chat.
Do you want to do it now? Let's do it now.
Yeah, I mean, if anybody wants to play along.
Give me a second. So it's repositories, mailysearch demo.
Fantastic.
Copy, and should probably post it to the. Should I post it? Yeah, no, I cannot.
Throw it in the private
Oops,
chat.
I lost my mouse. So.
Uh-oh.
Yep, here we go.
All right.
Also, mailysearch has out of the box its small, very nice, very small web interface, and I loaded all the books from my CSV file. Give me a second. So
yeah, what you're doing now. That a lot of time when we're doing search for things, we're taking data. This data, the CSV data, looks a lot like I might have a table in another database.
Yes, absolutely. Right? You can have this data anywhere. CSV is just a nice portable format.
Yep.
It's 77 megabytes of books. Each book has its own ISBN. It has title, author, year of publication, publisher.
Is this the Java books? Is that the Java books database? Okay.
No, sorry, because
I see that one as a popular one.
I wanted to have a relatively big data set.
Okay.
And sadly, there are not so many Java books. I mean, we can probably list like 50 Java books.
No, I think I've seen several demos that use the same set of Java titles or Java-related titles or software development titles, and it's pretty large. I typically use a retail stores database that's publicly available from one of our government organizations. So it gives you every retail store in the U.S. and their address and location, what type of store they are. So it's a nice little set to use. But I'm always we're always looking for that interesting demo and the interesting data set, because you have to find something that relates to the audience. So the audience here, I'm going to ask this question in chat. If you've got an interesting use case, what's the domain you'd like to see more often in demos? Tell me what it is. Something besides books.
Absolutely. Thank you so much for this question. It's just amazing. So as I said, sorry that it's not Java books. We have also several URLs to small URL of the image, medium-sized URL of the image, and URL of medium-sized image and URL of large-sized image. This application starts up relatively fast. Let's actually look at it.
So are you using Docker Compose?
Yes, it brings, it actually calls, come on.
Oh, I'm so proud of you, Pasha.
It seems like my mouse is slowly dying. It's a Bluetooth mouse, which is a shame.
I know that feeling.
Yeah, but we can see here that it actually found the compose file. Using
Yep.
Docker Compose file, now it's created, started, waiting, healthy. It took several seconds, and the whole thing started up in 318 milliseconds. It's a very small application, which still does something useful.
Wait a
It
minute.
can
Hold on one
load.
sec. Did you loaded all of that CSV data and started your application up in 318 milliseconds?
No, since it doesn't call Docker Compose down,
Okay.
it doesn't need
It
to
was
load
already.
all the CSV data.
Okay.
I
I was about to say, I'm impressed.
Yeah, so
Okay.
but what we actually can do, I have it somewhere here. Give me a second. So yeah, we can actually try to load the whole data. Again, it's almost 300,000 books. We
Yep.
can load them into our mail search. It takes not an awful lot of time.
Right. When is this a use case? When do we typically want to refresh our search indexes? When we've got data that's changing a lot,
Yes.
that search index, whatever it is, vector similarity or full index, when that's changing a lot, the speed at which you can load that data, that speed at which you can refresh, that becomes important.
Yes, we can also add books one by one. It will obviously be slower because we just will have to make a lot of round trips to the server. Even if it indexes infinitely fast,
Yep.
latency of the server will kill all the performance.
Yep.
But we can roughly estimate, what is it?
That's really good.
270,000 books. One book takes roughly one item in our case takes roughly 56 milliseconds to index,
That's
which
really
is
good.
not blazingly fast. But for most use cases, like imagine that it's a million entries, million records, it will take probably 20 seconds. Not blazingly fast, still very usable. And we can also try to measure how much does it take to query something from the database. I query 50 items from it. It returns the full bodies of them.
Okay.
So it obviously takes some time just to process the data, and we can see that it's like 15 milliseconds to look for love.
That's really good.
What should it be? I don't know. Death. I cannot type. I don't know why. Okay, what we can do they also have this very nice built-in web interface, and we can search in it. So looking for death took us roughly 4 milliseconds. Looking for all the books published in my birth year,
Okay.
1986, takes 3 milliseconds. Let's look for Java probably, right?
Yeah.
That's why we are here. Java took 2 milliseconds. There are roughly 128 results.
That's my benchmark. So just to be clear, like that is the bar that I measure everything, is that 2 millisecond response time. The other thing I notice is as you're typing, it looks like it's doing like an autocomplete or a best guess.
It's not doing any autocomplete as far as I know. Let's try to type slowly. Let's type Kotlin. Oh, oops, I can type obviously. Yeah, it doesn't do autocomplete. What it does, it searches on the go. Like
Yeah.
I add one more symbol,
Yep.
and
That's still very powerful.
yeah, it is. I mean, again, it's 270,000 results.
Yep.
I'm almost sure that it will be as fast on 1 million results, because this is the only thing they do. They only do searches. You can include and exclude fields. And yeah, here we can see that it's just, I mean, this is a very straightforward representation of item.
Yeah.
I'm not sure what happens if the item is more complex, like if we have complex structures in our documents, but the question is, do we really need it?
Right.
Usually we do not.
Right. This is powerful. Can you show us how things are indexed? When you pulled them in, when you did your import, can you show us what that did? Did we do anything extra? Did we weight the different columns any different at all?
What do you mean? So, do you want to look at the code of the loading the
Yes.
data?
Yes.
Oh, yeah. What we do here is we just read our CSV, and then item by item, we create a class called book with ISBN, book title, and so on. I do not measure anything here. I measure only this part. Index, add documents in batches, split it by batches in 10,000s. It actually makes things slightly slower, but we have our first results faster. It means
Okay.
that so first 10,000s are already there. We can already search by them.
Yep.
The whole thing takes 9 seconds, but the first part is obviously much, much faster.
Yeah.
So your users won't live without results any significant time. And then I just return that we saved how many books in how many milliseconds.
I like that. So my searches, I'm looking at your Git mapping for search. My searches, that's going across all of those fields.
Yes.
So I can put in an ISDN number and I'm searching across an ISDN number and I'll find those results.
We can actually make a, like, let's find something obscure. Something obscure. Obscure night. Okay, works for me. Oops. Also, it's a very interesting thing that there are multiple books with the same ISBN number. Probably it's some short kind of ISBN or something like that.
Got it.
It's just a random data set from Kaggle. We can also see that it took more time. It took 49 milliseconds for this ISBN. I don't know why, but also there are ways to exclude fields from search.
Yep.
It was somewhere here.
Yeah, those are kind of the things that you expect. Let's talk about when you're looking for a search implementation today, what are the things that you look for?
I honestly don't know. I am looking for different things. Let me switch.
You've touched on a few of them for me. I like to have a fast load because this was an important piece of what I was doing, right? I was doing data sets that were constantly being upgraded or updated from millions of people around the globe, constantly uploading data. And I wanted my search to work across that data. So I had to come up with some mechanism that allowed me to refresh the indexes, rebuild that database. And so that speed mattered.
This is usually important for my clients I hadn't passed. It was usually more important to have relevant results. It was some e-commerce business or something like that.
Yep.
And they didn't want at all when their clients type, I don't know. It was a question of prioritization. For example, if they type Android, then Samsung phones should be higher than Huawei phones or something like that.
Yep.
And I'm not sure how would you do it in Mail Search, to be honest. It's very relevant, but only to what you're looking for.
Yep.
This particular task, like synonyms and so on, I actually solved in Elasticsearch, and it was a huge pain. We actually had to cache a lot of things, like cache responses to all the popular requests, which still makes sense even with Mail Search.
Yep.
We cached them where? In Redis, obviously.
So me and one of my former colleagues, Senthil, we had this concept of the distance to the data. Like when you're searching, when I'm doing this search, like we indexed a bunch of books, and while I'm searching, that's really the only data that I care about. I don't need the book's contents to come back.
Yeah.
Right? So we had this kind of metaphor of this search cache layer that's where I'm going to do a lot of my interacting with, where I'm going to search and I'm going to find kind of those key elements, the product name, maybe a description of it. But those are the things that are come first. And if I ever wanted to like edit something, then I was going all the way back and I was getting the real object and I was making that change. And then that edit, when I committed that edit, when I saved that edit, then it would refresh itself in the cache. These are just some of the things that you have to be concerned about. If I'm constantly adding to that search index, does it readjust? Like,
Yeah.
does it re-weight? I asked the question about weighing different parts of the data. You know,
Yeah.
would I weigh the ISDN heavier than the product name? You can put weights to these different things so that when you're searching, the relevance, if it comes back and that number is a part of the title, that's going to show up first
I
above the
actually,
ICN numbers.
while
But
you were talking just now, I found that there are filters in my research, and you can actually assign different weights to different fields. So you can prioritize your title and your
yeah,
description better than higher than your ISBN and
yeah,
image names and so on, which is very important. Also, what I like about my research, they have put, you can actually update document
yeah,
and it's very fast. And
yep.
like, it just works. You do not even think.
And that's another part. That's an important part. This is another reason why I like these fast indexing, fast write databases like Redis. So my question on Search, is it in memory on disk? Is it splitting?
So it depends on it is spilling as well as ready spilling, but obviously it works in a most efficient manner when all the data fits memory. Otherwise, well, your disks are very slow
Tiered. Yeah.
inherently. You
Yep.
cannot do anything with that. But it works the same way with Postgres, for example. Obviously, it always writes ahead. They even
Yep.
have the write ahead lock, how they
Yep.
call it, because the data should be very durable. Mail search, as far as I know, doesn't give such guarantees. So it is possible that in one moment in time you will have to reread the whole index.
Okay.
As we saw, it's relatively fast,
Yep. Well,
but
the
well,
results
it's
that you
not a
showed were
real-time
good.
database, so it's not intended to have the old CP load when you read or when you write there all the time.
Yep.
It's mostly OLAP load when you analyze data. When you, it's built for one particular goal with
Yep.
one particular ID, and it should be very fast, probably the fastest in the world. I don't know. It's like the emission sounds full text search.
Yep.
Anything else is behind their scope. They can implement it, but we don't know. They definitely would not sacrifice the quality and the speed of full text search to anything else.
Yeah. This is powerful. This is a great demo. I'm going to jump a little bit of a tangent. I talked about hosting on Raspberry Pis, and this is just where my head's at. Right. Postgres is very popular.
Yeah.
With a lot of the communities that I deal with, a lot of the audience that I deal with, Postgres is kind of the de facto choice. But I also said that I want to live an active lifestyle, right? I
Yeah.
want to deploy things active. And there are not many active Postgres solutions. And I kind of like performance. So one of the other topics that I get a kick out of is having a fast write layer. Remember, I said I had this metaphor in my head, this
Yeah.
distance to data, and we've got customers, and there's tons of solutions where my writes are going to be fast. I'm going to make sure that my writes are fast and my writes are handled, but they're going to be handled at a different layer than where they are persisted for, yeah, for the rest of the time, right?
Yeah.
So this idea of a write behind or a change data capture mechanism where I'm going to write it to a Redis, but I'm going to actually have it persisted, made searchable in my Search.
Yes.
Right? I'm going to write to Redis because it's fast, but then I'm going to take that same thing. I might send it over to a Postgres implementation. Let's say Cockroach. I'll send it over there so that it's persisted and it can be active. But
Yes.
then I'm also going to send it over to Search so it can be searchable and indexed. But I can connect these different data sources to do these different implementations.
Yeah, what I would think about is actually storing all the data in Postgres, but querying it from Search. So every time you write to Postgres, you also write to Search. When you query data, when you full text search over your data, you do it only from Search. It's very simple to implement, actually. The only issue is, again, what happens if Search is not a traditional database. What happens if it loses some data? We should have some scheduled task that will just resync things. It's not, again, it's always some kind of trade-off, right? It's the whole development is some kind of trade-off. You should understand your business goals. If it should be absolutely durable, if you cannot lose any single point of data for any moment, then you should go with Postgres probably. You cannot go with Redis, you can go with, and you will pay for it with slower searches. I mean,
this is it, right?
You can tune Redis the way
These
that
are all
it
trade-offs.
won't lose data ever, but then you will pay with performance.
Yep, and these are all the trade-offs, right? I want fast writes. Part of this goal of being able to run on Raspberry Pis is to be able to like scale. Like, how do I say this? I've been challenged, not directly. Somebody said, "Oh, you can't do real hosting on Raspberry Pis. It'll fail. Why would anybody do real hosting on Raspberry Pis?" Hey, Keith, welcome in. And in my head, I know all the ways that I can make Redis work, and I can have these fast writes. And yeah, like the whole like transactions per second, how many transactions per second can you do? It depends, right? But I'm very comfortable, being in the millions of transactions per second, the millions of writes per second, with enough scale. And I know that I can do that, and can't always do that with Postgres. So if I can handle that with Redis and then have that right behind, again, every use case is different, but just in my head, that's where I want to be. So that's what I'm thinking about. But I like this idea. I like this idea of Melisearch, especially if I'm active. If I've got one region of my data that's being searched differently than a different region, right? My European customers versus my US customers, maybe I want those indexes weighted differently.
Yes,
so I can still be active, still pulling from that same Postgres source of truth, but in the different implementations in my different regions, I weigh things a little bit differently. Maybe I weigh the English language books. I weigh those differently than the German language books in the
German
US,
ones, yeah.
right? So I can do these types of things. Maybe, these are just examples where there's rarely one solution that fits all.
Yeah, what I love about Melisearch is API is pure HTTP. So it's very simple to build anything on top of it. For you, it's just different web service. If you can pull data from one of them, put it into another, you can reshuffle data, you can shard data. It's up to you. It's relatively simple to implement.
Okay. Another good feature.
Yeah, I like, one can argue it's a bad feature at the same time, right? Because it's JSON, they will say it's heavyweight and so on. Probably protobuf would be faster as at least more compact.
But just having options.
Again, the whole development is about trade-off management.
Yes.
It's the phrase I constantly repeated my subordinates when I used to be a principal developer. Folks, it's about our trade-off management, what do we expect, what we can pay, what we cannot pay for it.
Yep.
And it's also the truth about negotiations, right? When you do negotiate about something, you know your points, you know your ladder of decisions.
Yep. And similar to JVMs, I say that, hey, JVMs are one size fits most, not one size fits all. I find that a lot of databases are one size fits all. You can grab a database, you can create queues with Postgres, you can do full text search, and it'll work. You'll get by, but it's not the best solution. And when the need for a better use case comes along, then you might look at switching.
Might be the best solution for you. It just doesn't mean it's a silver bullet.
Right. Yeah.
So we are not saying, or at least I am not saying what's right or wrong for you. I have my ideas what can work for you.
So this is good. Now, this is my last question.
Right.
I saw Elasticsearch being used as a database, not just for search. It was being used just as a database. Yeah. Could Melisearch be abused in that same way?
Yes, they have filters. It means that you can actually filter by fields, why not? I do not see why not. I mean, to me, my research is very. I need a deeper research. Again,
Yeah.
on
Hey.
Elasticsearch, I have implemented complicated, crazy scenarios where one word is actually a synonym to another word. I'm not sure if you can do it in my research. I just don't know. But as a database, for sure, you have filters. Full text search is just another kind of filter in a way.
Yeah.
You can have all real like in MongoDB. Do we call it a database? We call it a database. It's just a document database as well as Elasticsearch and as well as Melisearch.
Yeah.
Just do not expect too much. It's not Postgres.
Yeah. This is good. Pasha, I always enjoy hanging out.
I mean, man,
let's do it
this
again.
is so cool. Let's do it again.
I have your demo, which points to your library. I put that in the chat. And then I'll say this for everybody that's watching. When you come to my house for dinner, if you leave hungry, that's your fault. I'm here hanging out with Pasha, brilliant mind. If you've got questions about anything we've talked about or anything else, ask now. I don't want you to leave hungry.
Yes, absolutely.
Right?
I'm happy to answer any questions. If you're still here, of course.
And if there's no questions, we'll call it good. Because what time is it where you're at?
It's 3 at my place, 3 p.m.
Okay. We are going to be, I'm going to be coming to Germany too. So I'm going to see you next week at DevNexus, and we'll coordinate calendars because I'm going to be not just like for a day, I'm going to be spending the weekend in Germany.
Nice.
So
yeah.
Germany. Let me pull up, make sure I get the names right.
Are you going to JCon?
I am not going to JCon. This is all customer visits the entire time. I am going to be in Karlsruhe.
Yeah. Johannesburg Berger lives there.
And then I think I'm going to be hanging out with one of my teammates, Timo, in Stuttgart for the weekend.
They both are very far away from me. It's like the whole country.
Okay.
Yeah, so it's 1.5 hours flight or 4 hours on train.
I'm taking the train.
If you are in Berlin.
Okay.
Well, anyways, I hope that we see each other on Spring.io. We definitely see each other on DevNexus.
Yes, we will.
And we'll see what else is coming.
That sounds like a great idea. Pasha, there's no questions in chat. Thank you so much for hanging out. And yeah, I'll look forward to doing this again. So everybody, thanks for hanging out with us. It's been a pleasure. And we'll see you next time. Take care.
See you next time.